Everyone, you're welcome back again. We're going to solve for the value of x from this exponential equation. We're given that 5 raised to the power of x multiplied by 5 to the power of x multiplied by 5 to the power of x is equal to 60. Then what is the value of x that will satisfy this equation? To solve this equation, the first thing we need to recall is multiplication property of indices. We say that when the bases are the same and there's multiplication, all we need to do is just to write one of the base, then we add the exponent. So the law is stated that, for instance, we have m raised to the power of x multiplied by m raised to the power of y. This is the same as what? M raised to the power of x plus y. So what happened here? As you can see, the base m and m, they are the same. So since as far as the bases are the same, even if the multiplication continue and the basis is the same, all you're going to do is just to write one of the base, which is the m, then we add the power. So the first power is x, then the second power is y, so we add the two power. So applying that law to this equation, to the left hand side of this equation, as you can see, 5 5 5, the bases are the same, they are 5. So all we need to do is just to write one of the base, which is 5, then we add the exponent, which is the power. So x plus x plus x is going to give us 3x, which is going to be equal to 60. So now we have 5 raised to the power of 3x is equal to 60. So the next thing we're going to do is to apply logarithm to this equation, because there's no way we can make this base to be the same. So applying logarithms, the variable we are looking for appear in one side of the equation, and the base of the left hand side is 5. So therefore we're going to take the log of both sides to the base of 5. So when we do that, we're going to have log of 5 raised to the power of 3x to the base of 5, which is going to be equal to log of 60 to the base of 5. So the next thing we're going to do is to recall power property of logarithm. So this power here, 5 raised to the power of 3x, is going to go back to multiply the log. So when we do that, it's going to be what? 3x, then multiply by log of 5 raised to the power of 5. All we just did, this power go back to multiply the log. So this is one of the property of logarithm. So everything now will be equal to log of 60 to the base of 5. So the next thing we're going to do is to recall one of the property of logarithm again. We say that a logarithm of a number to its base, when the number and the base are the same, is the same as 1. So therefore the whole of this log 5 to base 5 is going to be equal to 1. Then that 1 multiplied by 3x is the same as 3x in the left hand side, which is going to be equal to log of 60 to the base of 5. Remember, we're looking for the value of x. Now we have 3 attached to x in the left hand side. What do? We divide both sides of this equation by 3 in order to eliminate this 3. So we divide the left hand side by 3, and we do the same thing to the right hand side, so that this 3 can cancel this 3. So in the left hand side, we are left with only x, which is equal to log of 60 to the base of 5 to the base of 5, then everything all over 3. Now we have x to be equal to log 60 to base 5 over 3, but this is not going to be the final answer, because we need to simplify the right hand side to its lowest form. So what do I mean? We are going to have x now to be equal to this 3 in the denominator. We can factor it out, which is going to be what? 1 all over 3, then multiply by log 60 to the base of 5. 60 can also be written as 5 multiplied by 12. So we can write 60 as 5 multiplied by 12, then to the base of 5, right? So now we need to simplify further. X now is going to be equal to 1 all over 3 into the bracket of, as you can see this bracket, we have log to base 5 of 5 multiplied by 12. So we quickly recall this property. We see that when we have log of a multiplied by b to the base of c, this is the same as, this can be simplified as what? Log of a to the base of c plus log of b to the base of c. So when the term in the bracket is multiplication and we have this base 5, what we're going to do, each of them is going to share this base 5, but the operation is going to change to addition. So this is what happened here. As you can see, this log is equivalent to this bracket, log a multiplied by b to the base of c. Then we simplify as log of a to base c plus log of b to base c. So therefore, to transform this inside this bracket into this form, we are going to have log 5 to base 5 plus log 12 to base 5. So this is what we're going to have when we do the transformation using the property. Then this log 5 to base 5 is going to be log of 5 to the base of 5, then plus log of 12 to the base of 5. So this is equivalent to what is in the bracket using the property. So now we're going to still simplify further. We are going to have x to be equal to 1 all over 3 into the bracket of log 5 to base 5. Remember, in logarithmic of a number to its base is the same as 1. It's going to give us 1, then plus log 12 to base 5 is still the same as log of 12 to the base of 5. Now, finally, we are going to have x to be equal to, we are going to use this 1 over 3 to open this bracket. 1 over 3 multiplied by 1 is going to give us 1 over 3, then plus 1 over 3 multiplied by log 12 over 5 is going to be 1 over 3 log of 12 to the base of 5. And here is the value of x that satisfies this exponential equation. Thank you for watching, and please don't forget to subscribe and also follow this page for more video like this.